Let's work on part G now. So if the insurance company cannot differentiate between the two types of groups, would the second group insure themselves against the snake bites? So let's see. What's the idea now? The idea is that now the insurance cannot charge based on the probability of 0.1 of the second group. The guys who are better at avoiding snakes do not benefit from that. Rather, the insurance company will charge an average premium because they could have in that group people who are good at avoiding snakes and people who are bad at avoiding snakes. What would be that average premium? Well, that would be 1/2, right? The middle value between the best case scenario of having guys who are good at avoiding snakes and the worst case scenario, the guys who are not good at avoiding snakes. Now, we know that the premium that the guys who avoid snakes very well with a probability of 0.1, they would deserve a premium of 0.4. So we will keep that in mind, 0.4 over here, 0.4, plus what would be the premium of the other guys who are not good at avoiding snakes, just the regular bamboo cutters. We calculated in some previous videos, I don't recall what was it, I think 2 videos ago. So the premium for those guys would be equal to 2 euros. That's what we saw. The premium that we calculated in part D, that was 2 euros. So that's the 2 euros that the guys who cannot avoid snakes very well would have to pay. Now between 2 and 0.4 we must charge the middle value. So we multiply that by half. We divide that by 2. 2.4 divided by 2 is just 1/2, I'm sorry. 1.2 would be the new premium. That's based on the average value. Hope this makes sense. Now, with this in mind, would the guys from the second group who can avoid snakes with a probability of 0.1 insure themselves? Well, let's see. All that's changing right now is this. In the expected utility that we calculated in the previous video, in the expected utility of having an insurance and not taking precautions, because we saw there's no point of taking precautions since the probability of being bitten is the same regardless. Well, all that's changing is that the premium in the expected utility now is gonna be 1.2. So here we'll have 1.2. And over here we'll also have 1.2. Everything else is the same. We're still having that probability of 0.1. We're still having the probability of 0.9. The utility function is still a times square root of y. The only thing that's changing is the premium. Now with this in mind, if we work out the new math with the new values, our expected utility that we would calculate, so the expected utility of the second group, over here let's write it like that, the expected utility of having that insurance now would be equal to 13.38. 13.38. Now 13.38 would be with the insurance. The expected utility without the insurance of those bamboo cutters who are good at avoiding snakes would be equal to 14.4. That's what we calculated in the previous video. So we compare 13.38 with 14.4. 14.4, that is the expected utility of no insurance. Expected utility of no insurance. Now what do we see? Well, we can see that 14.48 is better than the alternative, so the guys will go for no insurance. They will not insure themselves because they are being charged too much. Like this premium of 1.2 euros is not worth for them to pay because the probability of being bitten is only 0.1, meaning that the good guys, the guys who are avoiding snakes very well, are not going to insure themselves. Now, what is the problem here? What is the analogy? This is very similar to what we had in the previous questions about work. When the good people, the good workers, are self-employed versus the bad workers work for company. The idea is this: the people who know can produce a lot of value would rather do it by themselves. The same analogy goes here. The people who can avoid snakes would rather avoid snakes by themselves without insuring themselves, because the premium that they have to pay based on the average probability between good bamboo cutters and bad bamboo cutters makes it unattractive for them to incur that premium. So meaning that the skillful, let's call the skillful bamboo cutters do not insure themselves. But again, that's not efficient. And why is that? Because we saw in the previous video that the expected utility of insurance is making the guys better off. So if that would be the case right now as well, then of course it would be better for them to take the insurance. But since they pay a premium that is becoming too large because the premium is taking into account the probability that these bamboo cutters might be unskillful, then it's not attractive for them. So the skillful bamboo cutters do not ensure, which is inefficient, which is inefficient. So this is a sort of adverse selection, meaning that the good guys, the good bamboo cutters, are going to go their own way and are not going to insure themselves with the company. But the guys who are worse at avoiding snakes actually benefit from that, because now they are being charged a premium of 1.2 euros instead of the 2 euros that they deserve, right? They actually should be charged a premium of 2 euros based on their probability of being bitten by a snake, but they're only charged 1.2. Why? Because that premium is dragged down by the fact that we have a group of good bamboo cutters. So the bamboo cutters that are unskillful at avoiding snakes benefit, but the skillful bamboo cutters are hurt. So they do not get the insurance, which is inefficient. Again, hope the analogy makes sense with the good workers versus the bad workers, and this is all just a set of examples to show what is the idea behind this adverse selection between information asymmetry, that whenever we're charged based on averages, someone benefits from that average, but someone who is good enough is actually hurt by paying that specific average. Hope this all makes sense, and we are done.